Hello friends, this video on equilibrium part 37 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Now we'll go through a very important topic called hydrolysis of salt and pH of their solution. So what is hydrolysis? See, hydrolysis, the word hydro means water and lysis means separation, right? That means breaking of the chemical bond by water. So water separates stuffs. Water breaks the bond. That is hydrolysis. Correct? So you put water in the salt breaks. That is hydrolysis. Right? The word hydrolysis means water breaks things. That means in case of salt, if you add salt in water, then you see that the salt is broken by water. So the point here is the water is not always the sweet water which we use, right? Water is sometimes scary, and that is in hydrolysis. Because in hydrolysis, water acts as the agent which breaks salt. So it's observed that if there is a salt of weak acid or weak base or both, when it dissolves in water, it is converted into acid and base. We'll take some examples. You have a salt of weak acid or weak base, put in water, it converts into acid and base. So for this, we use one more fancy name called KH. KH means K hydrolysis. Hydrolysis constant. That is nothing but concentration of acid by concentration of base by concentration of salt. Water is something which we ignore because it is a liquid and its concentration is constant, right? So just the same logic which we had for equilibrium, same logic will apply here. So the KH is nothing but concentration of acid, concentration of base by concentration of salt. And same thing, we had something called degree of dissociation here. There in the equilibrium, here also we have the fraction of total salt that is hydrolyzed at equilibrium is called degree of hydrolysis and is denoted by H. So there it was alpha, here it is H. Both are same actually, but H is specifically for hydrolysis equation. So the extent to which the salt is hydrolyzed is nothing but the degree of hydrolysis at equilibrium. So we told the salts are from weak acid, weak base, strong acid, strong base combination. How to find that? Given a salt, how to find that? So let's take three different salts and let's try to find whether they are salt of weak acid, weak base, strong acid, strong base, or which combination. Let's take CH3CONA. So if you see CH3CONA salt, if you break it, there are two ways actually. One easier which I'll tell you. CH3CONA. Just by looking at this, you can make out that this we have formed from CH3COH and NaOH. Correct? This is a very weak acid. You know that? And this is a very strong base. So you can say that this salt is from a weak acid and strong base. This is one approach. Or the other approach is you have CH3CONA, you break it, this becomes CH3CO minus and Na plus. And you also have H2O. We have seen that because in an aqueous solution we'll have ample H2O, which will break into H plus and OH minus. Now if you see on the right hand side only, what we'll have? So we will have in the solution H plus, OH minus, CH3CO minus and Na plus. I know that CH3COH, this acid reaction I know is CH3CO minus and H plus. And I say only very few, maybe 2% or 3% dissociate. Other is an acid. That means here also if I put a lot of CH3CO minus and H plus, the reaction will go in this direction and it will form CH3COH. So H plus ion concentration will be gone from the solution. Correct? See, because CH3CO minus and H plus, whenever they always have tendency to form CH3COH. Right? Because it's a very weak acid, CH3COH. Since it's a very weak acid, it will form CH3COH and the hydrogen ion concentration will be gone. So this thing is gone from the system now. And instead of this, we'll get CH3COH. So now what is remaining is Na plus NaOH minus. So Na plus NaOH minus, you know that if you have NaOH, it becomes Na plus NaOH minus, almost 99%. So if you have NaOH, it will try to become Na plus OH, Na plus NaOH minus. If you have Na plus and OH minus ions, they will never mix to become NaOH, right? Because it's a very strong base, NaOH, correct? So in the solution, the whole solution will have a lot of OH minus ions, correct? And if we have a lot of OH minus ions, the solution is basic. So this guy is a basic salt. So the question was whether the salt is acidic or basic. The answer is basic. So one option was just use this logic and understand this is a salt of weak acid or strong base. So here we found it strong base, weak acid. The stronger part was basic, so we told it is a basic. Another option is to understand the logic. You write the equation and this then you see that CH3CO minus and H plus it will always combine to form CH3COH. This part is gone from the system, the H plus is gone from the system. We have more of OH minus. Let's take it for NH4Cl. NH4Cl will break into NH4 plus and Cl minus. And again we have H2O, it will break into H plus and OH minus. So now if you see, I have either H plus Cl minus, NH4 OH minus. I know that NH4 and OH minus will combine together because NH4 OH is a very weak acid. It will form NH4 plus OH minus, very few, maybe 2%. So if you put NH4 plus OH minus together, it will form NH4OH, right? So 98% is this and 2% is this, that's suppose. So it will form NH4OH minus. So this is duplicated from the system. System will have more of H plus ion now because HCl, if you talk about HCl, it forms H plus and Cl minus ion. So here 99% is this and 1% is this. So even if you put a lot of H plus and Cl minus ion, it won't combine to form HCl. So we'll have more of H plus ions, so it will be acidic. Right? Also, if you want, what you can do is you can say that NH4Cl is nothing but from NH3 and HCl. HCl is a strong acid and this is a weak base, right? Strong acid. So which one is stronger? Acid part, so it will be acidic. So there are two different ways you can use any of these. So with the same approach you can find for CH3CO minus NH4. So CH3CO minus CONH4 will break into CH3CO minus and NH4 plus. And if you put H2O, this becomes H plus and OH minus. So here if you see, this guy will also form and this guy will also form. So it will be almost neutral kind of thing. Why? Because H plus and OH minus both are consumed in this case. Now let's talk about the hydrolysis of salt. We have discussed the types of salt now. And let's understand the hydrolysis of salt because the hydrolysis of salt depends on the salt quality. So if I have salt of weak acid and strong base, we just discussed this. Example CH3CONA looks like this. Or we have a salt of strong acid and weak base NH4Cl, it looks like this. Or we have a salt of weak acid, weak base, for example CH3CO, NH4. In all these cases, my hydrolysis behaves in different way. We will talk about this and we'll try to derive the relationship. So let's understand this because in all these cases, the hydrolysis behaves in a different way. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.